In this short video, I will show you how to set up the Agilent 3000 X-Series oscilloscope to perform eye diagram and pulse mass testing on a differential Arinc 429 serial bus signal. The first step is to download the various Arinc 429 mass files from Agilent's website. These mass files are available at no charge. After storing them to your USB memory device, then insert your USB memory device into the scope, and then you can begin making measurements. The next step in making this measurement is to probe the differential Arinc 429 bus. Agilent recommends using the N2791A 25 MHz differential active probe. Let's now set up the scope to perform an Arinc 429 eye diagram mass test. Begin by pressing the Save Recall front panel key. Next, select Recall, then navigate to the appropriate mass file. In this case, I'm going to recall a 100 kilobit per second iTest mass file, which is used to test all bits of all words received at the input of the remote device that I'm probing. When you recall this file, it will automatically set up the scope and begin accumulating and overlaying all received bits at our probing point. It then compares these acquired signals to the mask, which is based on the minimum and maximum input amplitude, edge speed, and clock tolerance specifications in the published Arinc 429 electrical specification. If the signal crosses through any part of the pass-fail mask region, as you see here, failures are clearly marked in red. Also note here the mass test statistics as well as the fast test rate. Since the scope utilizes unique hardware-based mass testing, this scope can test over 200,000 waveforms per second. Since we started this measurement, the scope has already captured and compared over 700,000 bits. Now that we know that we have a problem with just our ones pulses, let's set up the scope to perform a pulse mass test on just the ones pulses, along with full parametric measurement characterization of each pulse. So again, I'll begin by pressing the Save Recall front panel key, then select Recall, then navigate to the 100 kilobit per second ones test mass file and recall it. Again, the scope automatically sets up and begins performing a mass test on just the ones pulses. But when I recall this mass, the scope also turns on several measurements including the top amplitude, rise time, fall time, and pulse width. I can now compare these measurements to the published specifications. In this case, the minimum top amplitude is measuring approximately 5.5 volts, which is lower than the 6.5 volt specification. And although it appears that we also have a slow falling edge, this edge is measuring a fall time approximately 1.5 microseconds, which is within the 2 microsecond specification. Another key specification is the half-bit width measurement. This one is actually marginally passing. The specification is 4.75 microseconds. To learn more about Agilent's new InfiniVision X-Series oscilloscopes and how they can help you debug Arinc 429 systems, contact your local Agilent distributor and ask for a demonstration. Thank you.